Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on gastric juice. Now, before I proceed with this presentation lecture, as you can see on the screen, I'm showing you one histological slide, and this slide is very important for you because even though I have delivered the lecture on the histology of stomach, but in case if you are having any doubt regarding the arrangement of the cells, let's say the cells of the gastric gland and the cells of the mucosa and submucosa, and which are the structures that are present in mucosa and submucosa. So with this slide you can understand. For example, here you can read the title, that is figure 12.9, stomach, mucosa of the fundus and body, and transverse section. And the slide is stained with hematoxylin and the eosin, and we are observing this slide under the medium magnification of the microscope. So once again I am suggesting you that you go through all the names. All the names are very important. For example, the gastric gland, okay, and the cells, all the cells, all the cells. Then the muscularis mucosa, then the submucosa, then submucosa, what is there in submucosa, okay. So all the names. One more figure is there, and this one, this histological slide, in fact this is covering all the four layers. Let's say this one is the mucosa, then we know mucosa is followed by submucosa, then we are having muscularis externa, and the outermost layer, that is the serosa. So you go through this slide and prepare all the names. For example, rugae, mucosa, what the mucosa is made up of, what is there in submucosa, okay. So very important one, okay. Now coming back to our topic of discussion today, that is the gastric juice. Now we know, now we have studied the histology of the stomach, the layers that are present in the wall of stomach, and we know which kind of cell are present in the gastric gland. So gastric gland, they secrete the gastric juice, okay. And what this gastric juice is made up of, what is the composition of gastric juice? So gastric glands secrete 2 to 2.5 liter of gastric juice in the lumen of the stomach per day. So every day these gastric glands are secreting 2 to 2.5 liter gastric juice in the lumen of the stomach, and the pH of this gastric juice is nearly 1 to 2. So it is having the acidic pH. And the important constituent of the gastric juice, components, what this gastric juice is made up of. So in the gastric juice, 99.45% water is there, and besides the water, some solids are also present. So 0.55% solids are there, and in this solid electrolytes are present. For example, in gastric juice, Na plus, K plus, Mg twice plus, Cl minus, SCO3 minus, HPO4 minus, SO4 minus. So all these ions are present, and there is an inverse relation with the Na plus concentration and the acid concentration. For example, over here, as you can see, it is written acid secretion. As acid secretion increases, the Na plus concentration falls. So vice versa, If acid secretion decrease, then Na plus concentration is going to increase. So that is the meaning of this line. So with this we have completed two theory point for this presentation lecture. Now this third point is also very important one, because in this point all the names of the enzymes which are present in the gastric juice, okay, they are mentioned. For example, first one, in a gastric juice, pepsin is present. And pepsin is a proteolytic enzyme. That means it is involved in the digestion of protein. And this pepsin actually it is secreted in an inactive form. So the inactive form of the pepsin is known as pepsinogen, and this pepsinogen is secreted by this hormone. This enzyme is secreted by the cheap cells of gastric gland. So once again, the cheap cell of gastric gland, they secrete inactive pepsinogen, and when it is activated it is known as pepsin. So uh, when I will deliver the lecture on the digestion in the stomach, that time I will explain you how this pepsinogen is activated and how this pepsinogen is converted into pepsin. So now moving on the second enzyme. The second enzyme is the gastric lipase, and this enzyme gastric lipase is involved in fat digestion. The third enzyme is gastric gelatinase. Now what this gastric gelatinase is doing? See, in the connective tissue protein is present, and this protein is known as gelatin. So this gastric gelatinase liquefies this gelatin. That is the role of gastric gelatinase. Then the fourth enzyme, gastric amylase, and it is present in the small amount. Then in the gastric juice, lysozyme is present, and lysozyme is bactericidal. That means any bacteria are present which are harmful to us, so they are killing the bacteria. That means the lysozyme. Then carbonic anhydrase enzyme is present in a small amount. Then the urease enzyme is present, and this urease enzyme hydrolyzes urea to produce the ammonia. So this is the third point of our discussion, and this is regarding the enzymes of the gastric juice. Now moving on the fourth point of our discussion. Now fourth point is something related with the mucus secretion, mucus or the mucin. Now for this mucus secretion, there are two type of cells are involved. First is this one. For example, these are all mucus secreting cell, but since these are present on the surface, they are known as surface mucus cell. Okay, and this yellow color cell, they also secrete mucus, but they are present in the neck region, so they are known as mucus neck cell. So here these are the surface mucus cell, and this one yellow color cell, they are the mucus neck cell. So now we are discussing about the mucus. Now before I explain you regarding the mucus, you observe this mucus. This is the mucus, this one is the mucus. Okay, here also mucus. So this is the mucus they are showing. Now how this mucus is secreted and what is the role this mucus is playing, what is the function of this mucus and why it is secreted. So first there is a soluble mucus, and second type is the insoluble mucus. There are two type of mucus: soluble mucus and insoluble mucus. Soluble mucus is secreted by mucus cells of pyloric and the cardiac gland. So we know the stomach is divided into cardiac, fundus, body, and pyloric part. Okay, so the gastric gland of pyloric region and the cardiac region, they are secreting the soluble mucus. The gastric gland of pyloric and cardiac region, the mucus cell, they are secreting soluble mucus, whereas the insoluble mucus is secreted by surface favular cell. And what are this favular cell and where they are present? So this surface favular cell are tall columnar mucin secreting cell. Okay, and they are present, they are lining the entire gastric mucosa. Okay, so this is something regarding the soluble insoluble mucus. Now one more point is there for the mucus. For example, here in this point is also for the secretion of mucus. As I told you earlier that the mucus is of two types, insoluble and the soluble one. Insoluble mucus, as you can see, secreted by mucus secreting cell lining the entire gastric mucosa, and insoluble mucosa is a such viscid means it is thick, it is dense, whitish. Okay, whitish in color. It is like it is a gel like, and it is forming a coat over the mucosa. Okay, for example, here as you can see, this one is the insoluble mucosa. Okay, now when the food is there in the lumen of stomach, what happens? From this gastric gland, we know gastric juice is secreted, and this gastric juice is having HCl. Now HCl is important to activate the enzymes, but at the same time HCl can affect this cell adversely. So the epithelial cell or the columnar cell, they can be destroyed by the HCl. So to protect these cells from the adverse effect of the HCl, this mucus is forming a gel-like coat so that HCl cannot affect the columnar epithelial cell, that is the mucus secreting cell. So that is the role this mucus is playing. Okay, so this was the first line, and this mucus secreting cell also secrete the bicarbonate ion, and this ion make the mucus alkaline, and it is having a pH of 7. Okay, so this alkaline pH, and for this alkaline pH, this bicarbonate ion are responsible. Okay, so see, this cell also secrete bicarbonate ion which make the mucus with the alkaline. So the pH of mucus is 7. Okay, then I have already explained you this point. Okay, how this mucus is protecting. And soluble mucus, so soluble mucus is secreted by the gastric gland of pylorus and cardiac region, and the mucus cell of this gland, they secrete soluble mucus. Now the neural control or the hormonal control is not known for the mucus secretion, but it is assumed that when the food comes in the stomach and this food particle, when they touch, when they come in contact with this mucus secreting cell, so that time this mucus secreting cell, they start secreting the mucus. So no neural or hormonal control is known for the mucus secretion. Now moving on the sixth point of our discussion, and sixth point is related with the intrinsic factor. And this intrinsic factor, as you can see, it is secreted by parietal cells of gastric gland. Now what this intrinsic factor is, so actually it is a glycoprotein and it is secreted by parietal cell of the gastric mucosa, and these cells are mainly found, they are present in the fundus region of the stomach. Now what is the use, what is the role this intrinsic factor is playing? So see over here it is written the function of intrinsic factor. So it is essential for the absorption of vitamin B12. Okay, this intrinsic factor actually it is forming the complex with vitamin it is forming the complex with vitamin B12, and this complex ultimately finally it is carried to the terminal part of the ileum. So in the terminal part of ileum, vitamin B12 is absorbed along with the intrinsic factor, because the intrinsic factor is forming the complex with the B12. And so in short, intrinsic factor is a glycoprotein and it is forming a complex with vitamin B12, and this complex is absorbed by terminal ileum. Okay, so we can say intrinsic factor is involved in the vitamin B12 absorption. Now sometimes in some person there is a deficiency of intrinsic factor. So in this case what happens, the idiopathic atrophy occur. Okay, so idiopathic atrophy means this disorder in which the intrinsic factor is not secreted sufficiently, so it is self originating and it is originating without any known reason why it is occurring. So that is the meaning of this idiopathic atrophy. Now what happens to this patient, that the patient suffers from the serious disorder, and that disorder is known as pernicious anemia. So this is the sixth point of our discussion, intrinsic factor. Now moving on the seventh point of our discussion, this is regarding the HCl. Okay, first of all, which are the cells that secrete HCl? So HCl is secreted by parietal cell. Okay, and this parietal cell, they are also known as oxantic cell. Okay, now this cell, this parietal or oxantic cell, they form complex network of intracellular canaliculi. Canaliculi, now what is the meaning of this? So let's say one cell, then second cell, then third, fourth. Okay, so this is then some other cell. Okay, so if these cells are secreting HCl, so this we can say this is the canal and this is the canal, and this canal's very minute one, they join together and this is known as the canaliculi. So network of canal, that is known as the canaliculi. Network of small passage, that is canaliculi, in which the HCl is secreted. Okay, and this gastric gland, they are approximately secreting 2.5 liter of HCl every day, and it is having a pH of 1. So the pH of HCl is 1. So with this, we have completed the presentation lecture on gastric juice. I hope this presentation lecture will be helpful in your studies and in your exam preparation. My name is Manish Koshti sir. I am from Ahmedabad, India. Bye bye. Namaste.